Thanks for coming. Sorry for this organizational. So this is organizational DevOps, right? That's what the name of this track. My question to you, a few questions to understand actually who I'm going to be speaking to. Who of you actually think that who of you know what continuous integration is? Oh, good. And I guess pre-flight build is something which nobody knows, or somebody has some idea what it is. Good. So there's going to be some learning here. And who actually thinks that a continuous integration has something to do with DevOps? Because I think most of you might think that continuous integration is something from the dev side mostly, not the ops side. So we will try to resolve that potentially, like, not misunderstanding, but the understanding of that. So I will show you what the pre-flight build is. First of all, I'll tell you why continuous integration doesn't work in most cases, why in my experience it doesn't work, continuous integration, what problems it has. Then I will explain what pre-flight build is. And then I will show you four problems we practically have when implementing pre-flight builds. And I will show how we resolve these four problems. So it's going to be educational, it's going to be recorded, probably you will get back to it later if you get deeper into this problem. So it's going to be highly technical discussion, but hopefully some of you will learn something from our experience. So first of all, that's just 10 slides, not too long. First of all, I will explain why continuous integration doesn't work. In my experience, continuous integration, in a few words, it's the practice which programmers put in place in order to build the product. Every time programmers change something, they build the product together and deliver it not to production usually, because this is called continuous delivery, but continuous integration is where people integrate pieces together every time they change something. This is the practice which actually most professional software teams are doing right now. And the idea is that every time I'm as a programmer, I get the source code, I get it to my computer, I make some changes, and I put the changes into the master branch, and then the server picks it up, the server which is called continuous integration server, it picks these changes up, together with the whole bunch of code, tries to build it all together. If it's not buildable, then the server says, your changes are bad, do something with them. But the problem is that it's too late to give that information. When the continuous integration server says that your changes are not good, the changes are already in the master branch. So the entire team already knows that there's a problem. And everybody, according to the definition of continuous integration, everybody has to stop and do something with this problem. And this is what actually doesn't work, because nobody wants to stop. When we're talking about a team of 2-3 people, then yes, maybe they will stop and fix the problem, and then the development will continue. But in my practice, nobody does that. The entire team, if the team is 20 people, for example, they want to continue developing. They don't want to fix that one problem introduced by one developer. So no matter what the continuous integration server says, the development will continue. And people just start ignoring the continuous integration flag, which is red flag given by the server. So the server says the changes just made by Jeff is not good, but nobody cares. So that's how that's what I've seen in practice many, many times. The people just implement this continuous integration, they install the server, they configure everything, but when they start working actually, they in the next few days or a few weeks, they just simply start ignoring the information from continuous integration server. That's the practical, like what we have. And there is a solution, which is called pre-flight builds, and which we use a lot in our projects. The idea is that we should not allow Jeff to put his code into master branch unless it goes through the build server. So basically we do not allow Jeff to put anything into master branch, into main repository. The Jeff or any developer has to give the code to us, to some server, and that server will try to merge that stuff into master branch, running the full build. So in the traditional setup, Jeff gets the code, puts to the master branch, and then the server checks the code. In this idea, in the pre-flight build, we get the code from Jeff, test it first, and if it works, we put it to the repository. That's basically it, that's the idea. So again, the traditional I'm going to repeat it one more. The traditional setup, when we allow everybody to put changes directly to the repository, eventually the repository will be broken, and the information from continuous integration server will be basically ignored. Nobody's going to care about it. In the pre-flight build case, we get the code, we do not allow anybody to put their code directly to the repository. We allow them to give the code to us, to the merge bot, so-called, the merge server, and then that merge server will get this code, these changes, merge together with the master branch, test it first, and then put it to the master, to the repository. That's the idea of the pre-flight build. So to run this pre-flight build, we need some server which stays in front of the repository. In the continuous integration setup, the server stays behind the repository. Repository is the king. Repository accepts everything, just give me everything, I'm going to accept whatever you do, guys. There are 40 programmers, 20 programmers, a big group of people. The repository accepts everything, and then the continuous integration server is kind of a secondary element which passively checks what's going on, passively, because the time is already gone. The programmer who made the mistake or made some change which broke something, the programmer is gone already, it's 5 o'clock. He's not in the office anymore. And then the server picks the whole code up, tries to continuously integrate it. It doesn't integrate. What does the server do? It raises the red flag, but the office is empty. So we have the situation where the code is broken and nobody cares. And the pre-flight build, the probability of the situation is way lower because we check before we put the stuff into the repository. Who actually understood what I just explained? Awesome. Thank you. And now the problems. That's it. That's the introduction. That's how it works technically. And now I've done this for 3 years in different teams, in different setups, in open source projects, in commercial projects, and there are basically 4 problems with this thing. It's not as good as it sounds, this pre-flight build. And I've never said about that in the conference. I was talking about this idea in different conferences so far over the last year, and I've never said anything about the problems. And usually people were asking me, like, what about this? So today I decided to group all the problems together and explain what's happening, how do we resolve the problems. So that's why it's interesting. So the problem number 1 is called slow build. So basically it looks like this. There are 2 programmers, they make changes, they submit their changes. We work on GitHub, you can work on something else, so they're basically pull requests. So it's a queue of pull requests. One programmer puts the changes into the queue, another programmer puts the changes. So all of us, all the programmers who work together, they basically introduce changes. They say, I want to change this button on the screen, which it was red, it's going to be green. I want to change the text here. I want to introduce new feature. All of them want to do something, and they put the pull requests into the line, into the queue. So they stay one by one sequentially. And then we have the bot, the merge bot, which I just said, the server, the machine, which gets this request one by one and merges into Git master branch, just one by one. The problem is that it can't be done in parallel. So the Git will not allow us to do it in parallel. We cannot take 2 pull requests and try to test them in parallel and merge them together in parallel. The Git will not allow you. It will not allow us to do it technically. So Git wants us to put changes one by one, sequentially. And what happens if this time takes, instead of 2 minutes, it takes 1 hour? If it takes an hour, then reasonably, in one day, you can merge probably 8 pull requests, something like that, one by one. And what happens if the pull request, if the changes introduced by someone actually are not good, and the build and the bot says, I can't merge it because you just broke something. In this case, it returns this pull request back to you and says, go back and rework it. So if the build is long, if that takes too long, then it's going to be a serious problem, and I've seen it a lot. So, do you understand the problem? Because I'm going to now explain the solutions. So again, the problem is that it takes too long, and people just sit and wait. We have, say, 10 programmers, and we come in. I've seen this a few times. We come in and say, hey guys, you were able to push your changes to the master branch yesterday, and everything worked fine, but today you can't do it anymore. You have to give your changes to us, and we're going to merge them into master branch. And they say, okay, let's see how it works. I mean, this is kind of new, so they were able to push it immediately and continue doing something else. Now we are saying them that you have to give us the changes and wait for it. So you wait an hour, or maybe half an hour, or maybe half a day. If it's half an hour, they will say no problem. Half an hour is not a big deal for me. But if it's half a day, they will start complaining. If it's 2 days, then the programmers will go mad. They will say, I can't work like that, because I want my changes to go to master branch and get to production by the end of the day. I can't wait for 2 days. But if the build takes too long and there are too many pull requests, the line is growing, and sometimes I've seen 20 pull requests staying in the line, 20. So one programmer puts the pull request, but he understands, or she understands, there are 20 in front of them. 20 other programmers put something in there. The line is too long, and then it starts, everybody starts to complain. The management, programmers, everybody. And they start blaming us who introduced that idea. They say, hey, get it back, let us just push it to master branch. I don't want to go through your bot system. I don't care about the quality. I just want to put it right now into master branch. So that's the problem, which I call slow builds. And there are a few solutions. Solution number one, which is obvious, make your project smaller. If the build takes too long, if it takes half an hour for you to build your product, then there is some problem with the product. It has to take minutes. It has to take up to 10 minutes. If it's longer, there's a problem. Break down the project into smaller ones. Break down the repository into smaller pieces, and then you will be able to do the same, to merge them separately. So introduce this microservices or whatever, or subsystems, submodules, doesn't matter, but they have to be small. That's one solution, which I've never been able to implement actually, because it's not possible. People say like, this is a repository, we have it for years. We're not gonna break it into pieces. That's the way it is. So our build is, and the time of the build only grows. With time, it only becomes longer and longer. When you start working, the build is fast. Usually it's like seconds. In a few months, it's minutes. In a few years, it's going to be sometimes hours. And that's what I've seen many times. And this is so wrong. It shouldn't be that. It should not go over 10 minutes. You should really think about breaking the project into the repository into pieces. That's one solution to this first problem. The second one is conditional build. That was what we tried and it kind of worked. So when somebody makes a pull request, makes a change, there's a big code base. There are many files, Java files, PHP files, HTML files, whatever. And the build is basically automated build by Maven or Gradle or whatever you use, which takes all this code and compiles what needs to be compiled, packages all together, and creates some deliverable, piece of like jar file or some container, whatever. So in all these steps, the fastest, the compile, the packaging, most of these steps are fast. What's slow is unit testing and integration testing. That's even more slow. So the unit testing and integration testing, these are two pieces which make your build slow. So we introduced a feature where the build bot was able to see what exactly did you change. If you just change the text file or the HTML file, which is naturally is not covered by unit test, we can safely skip the unit test part. So our bot was able to understand whether the unit testing is necessary or not. In that case, some of the pull requests were extremely fast. Some of these merge operations. So some of them were like, not a few seconds, but less than a minute, and others are taking like 15 minutes or half an hour. So that feature, that was quite effective. You can check what is required. The merge could be clever enough to understand, according to the changes made, do we need the unit testing, do we need integration testing, or we can just safely merge because nothing serious was changed. It was just a piece of documentation change. Or it was just the text on the screen. There was the description of the product, and we just changed a few words over there because there were grammatic mistakes. Do we need the full unit testing? No. Do we need integration testing? No. We just package it and make it and call it a day. So that was the second thing which we implemented. Number 3, you need really big build servers. So if the build takes, if it takes too long, if the merge bot takes too long, then an obvious solution is to make the server bigger. So in my experience, these build servers are bigger than production servers. So in production, you may have smaller machines because basically first of all, there are many machines and they're basically commodity servers, which could be slower. But here, the machine should be really big. Should be really big and really powerful in order to basically save time of programmers. So if programmers have to wait for a long time until their pull requests get into master branch, it's so bad for them that they will complain. This is the most valuable time of the whole team. So investing money into this build machine is really something which we've done, and it really works. But it's not a perfect solution, of course. If the build takes half an hour, you can make it 5 minutes by just upgrading the machine. But sometimes from half an hour to 20 minutes, you can get easily by just making the machine bigger. So that's another solution. Solution number 4 is parallel tests. So by running tests in Java, for example, in all languages, it's possible to configure your build, the build automation software, again, like I said, Maven, Gradle, whatever, you can configure them to run unit tests and integration tests in parallel. Not just one by one, but in parallel. In that case, you will use the you will use all the processors, all the CPU power of the build server. So it's also, again, going to optimize your build and make it faster. And probably not the last one, but another obvious solution is you can configure your build there to fail fast. Because usually when you run the automated build, let's say in Maven, it's going to run all your unit tests and all your integration tests, and then going to report what the problems were. So the Maven will say, these tests actually failed, and going to give you the list of tests. But in this case, you don't need a list of tests. Basically, the first one which fails, it's enough for you to stop building and say, boom, you have just one broken test. I'm not gonna waste any more time on continuing to build because other people are waiting. So you have just one broken test, that's enough, and you return it back. In this case, a traditional build will take, say, half an hour for the whole project to discover, to run all unit tests and all integration tests to receive the full report of them. Then you don't need that full report in this case, you just need one first failed test. That will be enough for you to return back the failed pull request, the failed change. That's the solution. And basically that's the solution number, the last one, which we tried and never succeeded and was really a disaster, so I'm gonna suggest it, but I'm gonna say that you probably shouldn't use that, is basically trying to group these guys together. So when we have a line of pull requests, you have a line of 10 changes were introduced by 5 different people. Instead of going one by one, 10 times, running the build 10 times and merging it one by one, you can probably merge 5 of them together and get one change, and then put this one change into master branch. That's possible. That will save a lot of time because 5 people are going to wait for the whole line. They will basically merge this stuff together, create a bigger change, a bigger pull request, and then this bigger pull request will just drop into the master branch. It looks cool, but when you start doing that, you will realize that eventually some of these aggregated changes will have problems, and then it's going to be a big problem to find out who made that mistake. If there are 3-4 people, there are 3-4 changes, 3-4 pull requests, we put them all together, we create a bigger change, and then we can't merge them into master. Then what? How can we take out what's bad out of this? Because there's going to be some good changes and there's going to be some bad changes. So the problem will be how can I take it out, and it's not solvable in my experience. Actually, I've seen situations where we just put together all these changes and we try to merge them into master. We can't, we try again, we can't, some tests are broken, and we eventually just abandon this whole thing, throw it away, and start from scratch. So I would recommend not to go that way. I tried that, it doesn't work. So it's better to do something with the optimization to make it faster, to make them smaller, but don't group them together because that will create just organizational and technical hell.
Question.
Yeah.
You said that the merging will stop if there is a mistake, but how you overcome if the mistake is so big, so all the other commits have to wait then until this one is fixed then? What is code review?
Could you repeat the question for the
Yeah, so the question is, if I understood it correctly, so you're saying that if we have one change and we can't merge it there, but other changes depend on that change. So we basically we just can't merge, we take it out of the line, and then we're trying to merge others, but they need the first change, right? Yeah, well, it shouldn't happen because these changes, these guys who created this, they never knew about that one. So they should be independent. So they should not rely on the changes there. They can only rely on the master branch. So when they start making some changes, they get this code. They get the master branch, I change something there. I don't know what other people are working on. I'm just working on the master branch.
But they have to go sequentially.
They have to go sequentially, yeah.
But if the one fails, you have to fix then this commit before you can actually deliver further, isn't it?
Yeah, that's true. Yeah, if we can't merge there, then your change, your pull request returns back to you. And the bot says, I can't merge it, do something about it. And the bot continues to work on other pull requests. So then it's your problem as a programmer what to do, and then put your code again to the line.
Okay.
So you as a programmer, you work like this. I make some changes, I get the master branch, I make some changes, I put my changes into the line, and then it stays there, and I'm just watching. I'm watching and watching, okay, it's in the line, it's in line position number 5, position number 4, like in the phone line. And then position number 0, okay, now the bot is busy working on my change. It tries, boom, it breaks. Okay, now it's my problem, I fix why it was broken, and I put it again to the end of the line. And again, I stay there waiting. If the line is short, perfect. If the line is 20 positions, it's like on the phone call, you don't want to wait that long. You're gonna complain and say, I can't work like that. I can't wait 20 positions because, I mean, I need to get fast. That's what I mentioned. That's the first problem.
So the actual queue can be longer than.
It could be way long. It could be, I've seen 20. I've seen 20 positions taken for 2 days. So we just come in the office in the morning and then there's 20 already in the line. And we just, how can it work like that? If I put mine there, it's gonna be 21. So when it's gonna be merged? The next Monday? And then they will come to me and say, you introduced that system? How about you take it away and let us just push it to master? We don't want this bot, we don't want this line. We just want to work like we did before. And it's really a problem to actually argue back and say, no, it's so important because it's a quality control, because nobody's gonna break the master, because we check before we merge, blah, 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 this continuous integration sucks and this solution is perfect. And they're gonna say, you know, it's perfect, yeah, but we can't wait till Monday. We need changes now. And then, like I said, there are potential solutions, but you can implement, we tried most of them. Some of them work, some of them don't.
Did you change the order of the tests?
We run tests randomly, usually.
Okay.
Yeah.
Question. Just repeat the question.
Oh yeah, sorry, yeah. So the question is how exactly do we run the tests, unit tests, right?
Yeah.
Do we run them in the same order or different order?
Yeah, and especially when you only report one test back to the developer. Did you change the order of the tests over time?
It's a good practice, good question. So the question is when we report the test, the broken test, like I said, we only report the first broken test. We don't run the whole thing because it's faster. If one test is broken, we don't need to run the full thing. So the question is, which test is this? The first one, the last one, how do we pick? So it's a good practice to run tests, always to run unit tests and integration tests in a random order. You configure your build, the Maven, Gradle, SBT, whatever you use, to run your unit tests in random order all the time. So you have 50 tests or 500 tests, you don't know which order it is. That makes your build more stable for the future, more solid, because you never know which test. Because some programmers, most programmers, me myself, we write tests incorrectly, so they depend on each other. This test assumes that another test was already executed, and that's a terrible mistake. We shouldn't do it like that. But people do it. People assume that the previous test was already executed and already created some test file for me, so I can use this file in my test. That's wrong. So that's why we need to change the order of this test all the time, and then they will fail initially, but then with time they will become more and more stable. So we never know. We never know which test failed. So that was
so do you have also builds in the feature branches, or you only integrate into the master?
That's going to be the question number 4. So I'm going to cover it in 2 steps. Yeah, that's a good question. So the question was about feature branches. How we merge? Do we merge only into master branch, or we also support feature branches where people develop their own features? So point number 2, the problem number 2. There are 4 problems in total. This is problem number 1, slow build. That's the name of the problem. Slow build. That's a huge problem. The problem number 2 is called broken merge bot. So if this bot is broken, then the whole system is basically shut down. So nobody can merge into master because we do not allow them to do that. And then we say, everybody, if you want some changes to be merged, then give it to us, and the merge bot will put this stuff into master branch, and then the bot is broken. So this is a terrible situation. You can imagine that, because in this case, nothing is happening. Well, in the worst case, in the best case, nothing is happening and it's just down. We just restart the server or make a fix and we continue. What happens if the merge bot is trying to build, but for example, it's out of memory? The disk is full. So it tries to do something and it crashes in the middle, and it gives some wrong signal to you. It says, I can't merge your stuff because out of memory. So the programmer will basically get this error message, and the programmer will think that it's a bug in his code. So it will be really difficult for the programmer to understand whether the bot is broken, whether there's not enough space on the disk, on the server, which is running this stuff, or it's a bug in my software, which I just changed. So do you understand the problem? Yes? That's obvious. So how do we solve that? It's not so easy, but a few solutions. First of all, well, I haven't done that, but I should recommend it. So try to duplicate it. So try to build two bots, which will just normally just 2 servers, and they will work in parallel. I haven't done this, so I don't know how it works, so I'm just saying. Well, as usual, they recommend to duplicate systems, so maybe it will help you. The second solution is don't try, probably if you can, don't try to implement it yourself, this merge bot, and use some hosted solution from somewhere. So in our case, for example, we have our own hosted solution for that, which we created, and which is used for many projects right now, and I'm gonna do some marketing, do some promotion at the end of the presentation. So we use the hosted solution, which covers all our projects, and in this case it's more stable, because if you're just using one solution, one server for just your project, the chances that it will go down and you will not notice it are very high, compared to the situation where this server is used by hundreds of projects, and as soon as it goes down, immediately somebody will complain and you will fix it. So I would recommend to use hosted solutions provided by somebody else from somewhere. And that's just 2 recommendations. And now, more practical thing is, I would recommend to, well, when I started to implement all this about 3 years ago, it was just a big build machine where we were just running these builds in just basically different directories. It wasn't really good, and then we started to use Docker. So the Docker, probably you know what it is, the Docker helps you to isolate your builds more or less safely. So instead of using just one big server where just the same operating system is building just parallel builds, well, I mean, because we're using this server for a number of projects. So when there's a big server, a number of projects, or a number of branches, which I'll cover later, then many builds will run in parallel. This merge bot will do these operations in parallel, and they may conflict to each other. So the Docker will help you to isolate Docker or Rocket. You can use another, like any technology for Dockerizing, for containerization, yeah. So you can containerize your builds by putting each of them into their own environment, in a completely isolated operating system, and then run it over there. And then you configure your Docker, for example, you create a Docker image which is perfectly fine for your specific build, and that's going to increase your safety of the solution way more. So if something will go wrong, for example, out of memory or some problem with the operating system, the information, the error message will be cleaner. The information coming back to the developer will be made way more understandable, compared to the situation where the whole build is running on the big machine, where somebody else may touch my files while I'm running something by mistake. So the Docker is a perfect isolation of, perfectly isolates different builds from each other. So that's basically it about this problem. It's not really a terrible problem, because if it happens when it just takes a few hours or maybe a few minutes to fix it. But the biggest problem here is basically the understanding of who is broken, my build or your merge bot. So who is in trouble? Am I introducing some changes which actually don't work and it's illegal? If it's a true positive, or if it's a false negative. So what kind of information I'm getting if the build is not, if I can't merge? So who is in trouble? The bot, the server, or my changes? Understanding that may take time, and I've seen many situations where people are coming to the manager of this bot and saying, your stuff doesn't work. Your build, your merge bot doesn't work. Your server is can't merge my stuff. You know, take care of that. And then it takes time for the operators of the system to say, no, guys, this is your problem. You actually made some changes which actually make the code unmergeable. So these debates, these arguments back and forth, I've seen this many times, because programmers, they will try to blame the operators, the operators of this system, and the operators have to say back that no, it's not our problem, everything is clean. Like, look, other stuff is merged just a minute ago, or another build is perfectly clean another minute ago, so it's your stuff, so take care of it. But these debates may happen, 10 minutes, really. Okay, so we have 2 more problems. This is problem number 3, unstable build. That's also a typical situation. Then the build is when you build something and it builds now, but you can't build it in 5 minutes. This is called unstable build. This is really very typical for integration tests. So when there's integration tests, they basically depend on some services which stay usually around your code, not just inside your code. So unit tests are for testing your code, just your code, and integration tests is for testing your code together with other services. And they may fail, these services. So, and then the build will be unstable. So you get them from something from the master branch, you trust this code, you make some changes, you put it back, you can't merge. Why? The question is, I didn't change anything. I didn't make any critical changes. Why I can't merge it back? And the answer is the build is unstable. I've seen this many times. In any project, the build is unstable is a typical problem. The solution. The first solution is Docker, again. So the Docker will help you to make it isolated and make it reproducible locally. So the Docker will, if you run everything inside Docker container, you more or less isolate your code from dependencies around it. So your code will be cleaner and more isolated, which is good for stability. A typical problem which I've seen is where people using the build machine, which is connected to some special services here and there. Some firewall rules are configured, some connections are pre-configured, some IP addresses are written like pre-configured, and then the build runs perfectly. But I cannot reproduce the same on my local machine. So when I take the code to my local machine, I can't run the same. I only can run it on the build server. This is a big mistake. It shouldn't be done that way. So everything should be isolated inside Docker or any other containers. In that case, the stability of the build will just go up. There are three solutions. The solution number 2 for this problem is sometimes we can introduce a parameter, a flag, a configuration parameter to the bot, which will say skip the tests. So, like I said in the beginning, in the problem number 1, sometimes you just don't need tests. You don't need the merge bot to take the time and run all the full integration tests when I'm just changing one text here and there. So the customer comes in and says, we need to change the text on the screen. I'm changing the text, and then I put it to the merge bot, and I need to be able to say, don't run integration tests. Don't run all the tests, because they may fail. Because the build is unstable. So don't run all of them. Just package everything, compile, put together, and maybe put it to production. So we have this, in a few projects, we have this flag, which is like skip tests. So you put skip test, merge it, and no tests executed. Everything is just packaged, compiled, and merged into master branch. So that's a solution. It's not a perfect solution, because in this case, you basically skip the quality control. You basically turn it off, and it may introduce potential problems if you actually broke something, and then your code will go to master branch blindly. Nobody's gonna notice that. So in this case, we basically we compromise and jeopardize the whole idea of this quality control. It shouldn't happen on a routine basis, but sometimes it may. And point number 3 is that we sometimes may split integration and unit tests. So integration test is like heavy tests, which actually make the build unstable, while unit tests in most cases are stable because they're fast and they don't rely on anything else. So you can sometimes split them up. I mean, they're usually split up. They usually stay in different folders or in different categories, but you can also configure your merge bot to only execute unit tests and no integration tests. That's solution number 3 for the problem number 3. And then the last slide, the Git flow. That's the one we discussed, the one mentioned before, the features and everything. That's the most tricky one, and I'm finishing. So here's what may happen. You may have a number of branches, not just the master branch, where you just put your pull request in there, and the bot just takes it from here and put it in the master branch. That's the easiest way. In a more complex configuration, you will have a number of branches. For example, this production branch and master branch. All the stuff goes in here, while to production we put only stuff which needs to go to production right now. There could be many different configurations. For example, this could be a feature branch. So we're developing feature number A, and then we merge our stuff into feature number A, and at the same time, we want this code to drop into master branch. Sometimes, so there could be configuration. This is one example. I'm going to talk about one example. We have production branch. I put the code in there because it's a hot fix which needs to go to production, but I also want this fix to drop down into master branch. That's one typical configuration. The problems here, there's going to be many different conceptual organizational problems. And why it's a problem? Basically because you're touching 2 branches. And by touching 2 branches, you need to run 2 builds. So you need to merge your stuff here and check whether it's still buildable. And then you need to merge it down and check whether it's still buildable. So you need to run 2 builds. So your merge bot has to be smart enough to merge here, build, merge down, build. So there are 2 builds, and then it pushes everything to Git. That technically sounds not so difficult, but conceptually it may be difficult. The biggest question is merge conflicts. Because what happens if you merge it there, and it's clean, the branch is good, it is mergeable to master, but it can't be merged down. The programmer cannot solve this conflict, because the programmer cannot make this branch mergeable into both branches. It's just technically not possible in Git. So I make my branch good enough for the production, but at the same time, it's not mergeable down, and I can't resolve that technically. I mean, there are two different merge conflicts which can be resolved at the same time in one branch. So we made I'm not going to describe how many more problems could be here. That's probably for the next talk sometime. But one solution which is practical, we introduced in one of the projects, was that the programmer was submitting 2 branches. The one branch is my changes, and the second branch, we called it supplementary branch, which was used by the merge bot if this stuff cannot go down. The merge bot was getting my branch, putting it into production, and then trying to merge it down. I can, and gets the supplementary branch, merges on top of master, and then this stuff goes down. I'm not sure everybody follows that, but this is probably for the future to think about. So this configuration of this pre-flight builds, that's my point, and I'm finishing. The configuration of this pre-flight builds may be quite complex. The more you get into it, the more you use that idea, the more you use that concept, then the more sophisticated and complex your configuration will be in your real project. So our problem was, like I'm saying, with the supplementary branch, which I think probably we're probably the only team in the world who was using that approach, but that worked. That worked, and it still works in the company which were introduced that about 2 years ago. So that was 2 branches. You submit the changes in one branch, and then you submit another branch which helps the bot to merge these guys together into 2 different destination branches. And I'm finishing, so this is my last slide. So this is the system which I mentioned. So this is the system which we created about 2 years ago, which is a hosted solution, which does all this stuff, and it's free and it's hosted. So when you have a project, your project on GitHub, you don't need to, it only works with GitHub now. So you don't need to build this whole thing yourself. You don't need to build this merge bot yourself. You just go in there, there's no registration even, you just start working with it. It's quite simple, quite easy. It integrates with GitHub, it works on Docker, it uses Docker containers. It does everything I just explained now, except this supplementary branch. This feature is not there, so you will have to, you will have to configure it the way you need it. But in the basic configuration, it's quite simple tool, which does exactly what I just mentioned, and resolves most of the problem which I mentioned. That's it. Sorry for taking that long. Thank you. Do we have time for questions?
We've got 1 more minute.
1 more minute. So probably it's not enough for questions. We can talk later, right?
Anybody? Nobody?
It's going to be video recorded, so you probably, I cannot imagine that probably most of you didn't really understand, are not able to apply that to your day work, because this is something probably new for you. But come back to that later. Keep it in your head. This is the solution for the future. The pre-flight build is actually what solved the problem for programmers on the long run. This is the right way to manage programmers and to manage their changes. And when you start implementing them, you will definitely have that problem. So you will probably get back to this video and listen to it again. Okay?
Thanks very much. We've got 10 minutes break. Just to refresh your memory, in the technical DevOps room, there's patterns for infrastructure as code.